Yeah, that sounds great. I have some slides which I can go over, but the most of the time I thought we could do some live coding and some Q&A on contracts, and also maybe like like put together some contracts that we might work on together based on like features that people find interesting. But yeah, so I'm Isaac. I've been building on smart contracts for about 5 years in Ethereum. So kind of before NFTs, was working on a lot of different smart contract projects, some DeFi stuff, some identity stuff, and then for the last year or so, been helping out more NFT projects. So experimenting with different systems for like dynamic tokens or tokens with on different networks. Also creating just like starter apps and tutorials for places like Rarible. So yeah, that's kind of a quick intro to me. I'm happy to jump into slides unless anybody else wants to say hi and kind of talk about maybe some context about how familiar you are with smart contracts. I'm just going to assume basically no smart contract familiarity, but some familiarity with blockchain. Yeah, just kind of curious about what the general background knowledge is for a few people. If not, I'll just dive right in. Maybe everyone can at least say hi, so I know I'm not speaking to an empty room.
Hello.
Hello.
Thank you. That way, I'm just not just like
Hi.
speaking.
Hi.
And
Hey,
thank you. Very helpful, actually. Yeah, feel free to jump in, unmute, and chime in at any point in time. So let's see. Let me share this whole screen because then we can do once we get to some coding sections, we can play around a bit more as well. So can everybody see? What am I sharing? Yeah. Cool.
Yep.
So first, like what are smart contracts and why are they important is kind of the why we're meeting today. I want to go over some like basics in these slides, just have like maybe like 10 slides or so, and talk about like how this actually applies to NFTs, which is probably the primary interest of the folks in this group. And then after that, there's just a lot of like the main thing that I'll just say right up front, the main thing I want you to take away from this is that by learning a bit more about like kind of the guts of smart contracts behind NFTs, you can do like a ton more like kind of interesting, dynamic, and engaging stuff without like adding actually a whole lot of complexity. Like once you just start to understand a little bit of stuff under the surface, you understand like what it means for something to be an NFT, and then also like kind of where the rules end and where you can like push the boundaries. Because I think that's where like a lot of the most interesting stuff is happening, at least as far as like the smart contract interactions between the art, between like the collectors and the artists and stuff. So I like to think of like smart contracts as the main thing that differentiates things like Ethereum, Tezos, Near, Solana from blockchains like Bitcoin. On Bitcoin, it pretty much does like one or two things. Like it emits new tokens to miners, and it allows users to spend those tokens. There's not a whole lot of programmability there. It's like the way that you can kind of visualize how Bitcoin works is imagine you have like a gift card to a restaurant. You go to that restaurant, you use up like it's $100 gift card. You use $90. And then they give you a little receipt back that says, okay, you still have $10 on this gift card that you can spend. That's actually that's all how Bitcoin works. It's just everything is kind of like those little receipts that tell you how much more money you can spend. And, imagine if you got to the point where you had like 50 different receipts that all said, okay, $10, I have $10 on each of these receipts. If you wanted to, you could combine those into one bigger gift card. So Bitcoin, it's useful, but it doesn't actually allow for a whole lot of programmability. Any programmability that you try to do on there is like a hack. Then there's like chains like Ethereum where it's purpose built for this kind of customizability and application development. So these can be both financial or non-financial applications. And then rather than just having fees based on like network congestion and like different people wanting to spend money at different times, fees are actually also include things like computational complexity. So if you're running an application that needs to do a bunch of like rendering stuff inside of the contract, or like loops through large amounts of data and sends tokens to a bunch of people, like all of these things add to the fees of the network. But like you can do so much more on networks like Ethereum, Tezos, Solana, or Near than you can on other networks. So you can use smart contracts for anything. Often, what they're really good at are like managing Web3 native assets. So things that, like imagine that you want to build like an escrow tool, or you want to like fractionalize an NFT and create new tokens. Anything that involves like just straight up like managing digital assets, smart contracts are great at. They're also great at just timestamping information. So like being like a notary for something happening at a certain point in time. They're also great for like removing middlemen from different applications. So you can have like direct peer-to-peer marketplaces for trading and lending. Again, like all kind of Web3 native assets. You can use them for anything, but there's things that smart contracts are not great for. So smart contracts by themselves don't know anything about the outside world. You could not easily write a smart contract that like responded to the weather or responded to any sort of like real world outside stimulus unless you have some sort of like trusted system for bringing that information in. Smart contracts only know about other data that exists in smart contracts and blockchain. Anytime you have to bridge data in, it gets significantly more complex. They're also not great at storing large amounts of data, especially on Ethereum, where it costs like I think it's been years since I did this calculation last, but actually we could probably do it live. Go ahead. Oh, sorry. So it's like if you think about you can get like a 64 gigabyte SSD card right now for probably like $20. If you were to store 64 gigabytes on Ethereum, it would probably cost like millions, if not like tens of millions of dollars. But that's not really the point of Ethereum. Like you wouldn't use it just as like a data store. It's also not great at keeping things private because by nature everything is transparent, and there are methods for obfuscating data, but you should never put anything on a blockchain that you don't want eventually to become public, because there's this kind of a assumption in the cryptography space that someday all encryption will be broken. So even if you encrypt data and then put it on a blockchain, 100 years from now, that data could become public. Maybe it's not. Maybe who cares if it's public 100 years from now? But if you do care, then like no matter how much you encrypt something, you don't want to put it on a blockchain and use a smart contract. So NFTs are a particularly good use case for blockchains because most of the time we're talking about purely digital assets, or situations where like it's a digital twin to a physical thing. There's also generally decentralized control. The reason why I say most of the time is because you can actually program whatever rules you want into your smart contract. If you wanted to make an NFT contract that you could steal the NFT back from anyone at any point in time, there's nothing stopping you except for kind of the cultural norms of the space, and people might hate you for it. But maybe make that a feature. And like that's kind of how I think about it, is like, yes, there's things that you culturally shouldn't do, but like unless you could turn those types of features into a unique differentiator, where like, okay, at any point in time, anyone can steal anybody else's token. Like what might that do? It's probably not good for the regular collecting market, but maybe it's fun for a different kind of game. It's also great for the fact that we have a standardized interface. So the reason why so many like galleries and marketplaces can exist around NFTs is that no matter who creates the contract, we all agree to like some basic standard. Standards are the thing that make smart contracts actually scalable. Like imagine if I came up with my standard for on-chain art, and then one of you came up with your own standard for on-chain art, and maybe they're like 90% similar, but we're using different function names, we're using like different ways of storing the data, different ways of accessing the data, different like metadata structures, while we're both creating like on-chain art, if we're not abiding by the same standard, then there's really no way to build a whole economy around a real economy around any of this stuff. So standards on top of the smart contracts are what make things actually work. So standards can evolve. So many years ago in Ethereum, we had the ERC20 standard, which if I actually look at EIP20, we can like go back in time to 2015 and see like the original proposal for an ERC20 standard. And this was a way where core developer and like founder Vitalik and Fabian, like they decided like there needs to be some simple way for everyone to create the concept of a token. And there's many ways to do a token that are like pretty good. But they wanted to like, okay, what's the most bare bones things that a token needs to have? A token needs to have a name. Technically optional, but pretty much all tokens have names. A token needs to have a symbol. That's how like when you go to Etherscan and search for like Decentraland tokens, it knows that this symbol is mana. It knows that it's Decentraland. Like the reason why all of this metadata can exist on here for any ERC20 that you find is because they all abide by the same standard. Imagine if instead of name, they just like somebody else decided to call it like token name. That's a perfectly reasonable name, but it would make it so that these types of systems wouldn't be possible. So we need to abide by certain standards so that the whole so that the industry as a whole can scale. But that doesn't mean you can't push the boundaries. If we look at CryptoPunks and like Dada, Creeps and Weirdos, like both of these were like collectibles from before the ERC 721 standard, but after the ERC 20 standard. They're not quite either. But if you look up, for example, like a Dada token on Etherscan, it thinks it's an ERC 20. Like if you can see max supply, holders, transfers, like it has all the same metadata that the Decentraland token has, but it doesn't behave the same way. And that's because like punks and the creeps and weirdos, like these were like some of the first contracts to think about like, okay, what if every token actually was associated with some sort of unique art or unique imagery? So they might look like ERC20 tokens, but just the transfer function is different because in ERC20 world, every token is the same. Like no one cares if you have $1 bill or another dollar bill. That's like an ERC20 token. And an NFT, each token is unique. And then in this middle, which I just called like ERC20++, it's like how punks and the Dada tokens work, where each token has like a unique index. It's kind of like a token ID in the ERC 721 world. So the reason we got to 721 is because there were like people kind of pushing the boundaries of what ERC20 could do, and that got us to the point where now if we actually like look up an NFT, it's very distinct from an ERC20. Like we can see, okay, this is actually tokens with artworks. So like standards are not a rigid thing that you have to abide by. They're like just there to make the space function. But it's highly encouraged to be pushing the boundaries of like what you can of what you want to do within these standards. Quick pause. Any questions, comments about kind of like standards, anything like this? All right, I'll continue. So what are the most core pieces of a ERC 721 smart contract? So we need to be able to read like the name of it, the symbol of it. I would argue that the absolute most important thing in the ERC 721 standard is this token URI. So token URI makes the entire space work. It's a way for you to like see a smart contract, ask it, are you an NFT? If it has a token URI and it returns you some data, then you can assume this might be an NFT. Like you don't, in my opinion, like you actually have to have anything else. But token URI is like the standard way of saying, okay, hey, NFT, describe yourself to me. And within that, you can have a ton of creativity. Like you can make it just return a a URL to a place on the internet. Like that's the most simple version where it's just like a static file. Maybe it's a video, or maybe it's something like much more dynamic where it like depends on who holds it, or it depends on how many times it's transferred. Like, but the most important thing about the ERC 721 standard, I think, is this token URI field. You can actually go here and if you're curious and like read about like some of the logic that went into defining the 721 standard, and like what they chose to include, what they chose not to include, and the intended implications. So beyond implementing, I think beyond just implementing token URI, there's not really any rules. You're free to do whatever you want with smart contracts. Like it's just, this is why it's important to know how they work, is so that you know how to push the boundaries. So like what are some examples of things we could do? What if we wanted to change the content every time that it's transferred? Like I think there's this audio NFT. I'm not sure if it's DefB for another artist, but every time these audio NFTs are transferred, it actually sounds like it was copied from one tape to another. So it like the audio quality deteriorates a little bit. Like that's an insanely cool dynamic where it's like the more you transfer it, the more loss is gonna accumulate over time. Change the content on Tuesdays so that when people log in to see their token, it looks different on any day of the week. You can do that also. Change the content based on who owns it. So if it's owned by somebody who also owns another token, it can look different. If it's owned by somebody who doesn't own that token, it can look different. You could even like mint tokens to people when they transfer it away. So like you could basically have this little badge that stays on their account that's like they owned this token at some point in time. You can have tokens that own other tokens. You can have tokens that are owned by multiple people. Like there's really no rules here. The marketplaces might not all like work nicely with you if you start like pushing the boundaries, but that's like kind of the point in my opinion. So so this is like kind of getting towards the end of just like slides, and then I just wanted to do some exploration to just show you guys what it's actually like to edit a smart contract and start messing with the rules. But if you are interested in learning how to code smart contracts, this is like to me the best resource. It's called Speed Run Ethereum. It actually helps you start with an NFT example where you get your computer set up, you run a few commands, and then before you know it, you've like actually deployed a smart contract and are interacting with it on your own UI. And then once you get to that point, you have a setup that you can use to start like tweaking things, changing the rules, maybe adding a sales component to it. This is like, I think, the best resource, fully free resource with a great community that can help. Has anyone here like written a smart contract, either on Ethereum or any other chain? It's okay.
I have not, but I'm definitely interested. This was a class that I was most excited for, because I don't know, there's like an art form that can be had just through smart contracts.
Yeah, absolutely, totally agree. And there's a lot. So I would recommend doing all of these challenges. There's once you get to challenge 6. There's actually like kind of on-chain SVG NFTs where you can like start messing around with like how the data gets rendered. But like beyond that, like the actual contracts themselves, like interacting with the contracts is definitely an art by itself. So a lot to explore there. I'm going to deploy. I'm going to get something set up just so that we can start messing around with things. So let's see. Let me go to all right, so I'm going to set up a local development environment that I use when I'm writing a smart contract. And this is like a template which is open source, and you'll all be able to use it. All that we have to do to get it started is run yarn chain. What this command does is it sets up a local blockchain that only exists on my computer. and it gives me like 10 addresses with 10,000 ETH each. All fake money, and it all only exists on my local computer. But it's like a really good testing environment for like interacting with something without having to deploy anything publicly. If I run yarn deploy, yarn is just like it's called like a package manager. When you're doing like JavaScript development, it allows you to like bring in other people's code to help you like bootstrap your own application. So in just those two commands, we've now created a local blockchain that only exists on my computer, and deployed an NFT smart contract to that blockchain. And now I'm going to create a website to interact with that with a third command, which is just called yarn start. And so now if I go to, it might need to boot up for a second, but actually we're already here. So now this is a website that only exists on my computer, which is interacting with a blockchain that only exists on my computer, and I can grab some fake money from my fake blockchain and start playing around with it. So if I click mint NFT, it's already done. So what this did is it used like some standard metadata, and it created an NFT that in my smart contract and minted it to me. I can do anything that you would normally do with an NFT. Where let me actually open this up in a new window, and I should have a different wallet. So I can transfer it from this account to another account. So transfer, and there it is. And if I want to, I could transfer it back. And now it's there. So like, it's just, this is like this super simple test bench where we can start messing around with stuff. We can look at all of the actual methods of this smart contract. So we can look at like the token name, the token owner. I can look at like, okay, who is the owner of token ID 1, which right now I guess is not giving me the real answer. The total supply of it. So if I minted another one, and if I refreshed, you can see that total supply is now 2. So like this tab, this Debug Contracts tab, gets you direct access into messing around with the smart contract methods. And then these screens are like simple like UI elements. We can also like look at all the events of transfers. So here's it's just very simple like a NFT example. And let me pull up the contract itself. I'll close all of this code. All right. So the contract that we are using is this one called Your Collectible. The thing that I like to do when I'm first starting to understand like how a new smart contract works is just get it up and running locally, and then just start making like tiny changes. So what are some tiny changes we could make? Let's change the name of the contract from Your Collectible to My Collectible. So I haven't saved anything yet, but if I go back to this page, under Debug Contracts, I can see the name of this is Your Collectible. So let's save this, and then let's deploy again. And now if I refresh this page, it's now My Collectible. That's just one little tiny tweak, but if you download this, follow along, and do that, you've already basically started writing a smart contract. People very rarely start writing a smart contract from scratch. Open Zeppelin is this fantastic resource of open source smart contracts that you can use to get yourself 90% of the way to your application. If you're finding that you're like having to write absolutely everything from scratch, it's a good practice just to do a little Googling, read some blog posts. As long as I've been building in ETH, every time I think I have a unique idea, the next day I find somebody else that just finished that exact same thing, which is both like crushing sometimes, but also like really nice because there's always resources for doing what you want to do. You just kind of have to get used to the fact that your unique ideas are few and far between. But if we could look at OpenZeppelin, and actually another great resource is Solidity by example. We can see just like what are all like the common things that people end up needing to do in Ethereum. Like let's say like sending ETH. So like if you're in a smart contract and you're like, okay, I need to transfer somebody just bought something for my contract and I need to transfer it to my Gnosis Safe wallet. What is the safest way to call this function? We can go to Solidity by example, look for sending Ether, and basically copy paste code into our contract. The best contracts copy paste a lot of code from other already audited contracts. It's like part of the culture. There's no expectation that you're writing things from scratch. You should take as much as possible from what exists and is out there and audited, and then add your own unique twist on top of it. But it's in software development, and especially in blockchain smart contract development, highly encouraged to use open source trusted code. It just gets you there a lot faster, and it ends up being a lot safer for anyone that's interacting with your contract. There's little things that can be that can lead to disaster in smart contract. Like there's this bug that was reentrancy. So there was this. There was a hack like last week that somebody lost $624 million. But that was like that was not a smart contract hack. That was like a corporate security hack. But there was one of the original DAO hack back in like, I think it was 2015 or 2016. People pooled a bunch of ETH into a single smart contract that they were going to then use as an investment fund to support the crypto ecosystem. Somebody discovered a vulnerability in that smart contract that allowed them to drain all of the money. And like, if you're not a developer, or even if like you didn't know about this, like this would be a pretty hard bug to spot. Everybody now knows about this bug, so so it's like something that usually gets caught, but still gets exploited sometimes. And here's like kind of how it works. So imagine that we have a smart contract that's storing like the balances of people that deposit money into a pool. So I send an ETH and it gives me a balance that's like, okay, Isaac has a withdrawable balance of 1 ETH. And then I went to withdraw it. When I do withdraw, it's very important to decrease my balance in the contract before you actually send me the money. And I know this might sound a little like intricate or complex, but like the reason is that I could actually write a smart contract that responds to when it receives ETH. And so if I went, and so this is actually how the DAO hack happened. Let's see. So here is the thing that's storing ETH. I deposit money and it increases my balance. And then I want to withdraw that money. And so it grabs my balance. It's like, okay, make sure they have some money. And then it sends me the balance. And then it sets my balance to 0. Sounds reasonable. But I have this attacking contract that when it receives money, it goes ahead and calls withdraw again. So first the money is sent. And then my attacking contract says, ooh, I received some money. Call withdraw again. Send some money. Oh, I received some money. Call withdraw again. And it actually never gets to this thing where it sets my balance to 0. It's like if you were withdrawing money from an ATM, or I don't know. Like I can't actually think of a good like real world example because this is like kind of a blockchain specific thing. But like this is a very if they just moved this line here and this line here, people would not have lost hundreds of millions, now probably like billions of dollars in value. So like there's kind of a weight to developing in smart contracts to understanding these patterns. And it's great to just like look to examples before you because other people ideally have already run into those problems. So any questions on losing money and hacks?
I think there's just one question. It's not about this, but it's about Shabari who's asking, is there a specific software to make a local blockchain on your computer, or is everything bot code?
Oh yes. So the test suite, the local development suite that I use is called. I don't know why I just Googled hard hat. Actually, given my search history, when I search hard hat, the first thing that comes up is Ethereum development, which is nice. So this is my favorite like local development environment. It creates a local blockchain. You can actually use it to create what's called a mainnet fork also, where you can like take the whole state of the main Ethereum blockchain and make a local version that only exists on your computer. And then you can like write a contract to simulate what it would be like to interact with the main Ethereum network. But you can do all of this for free without having to spend real ETH. So Hard Hat is my favorite development environment. And then Scaffold ETH, which is what you'll see here, is like my favorite development suite. It gives you a default user interface with all the components you might need to use. It gives you a hard hat environment with a local contract. It basically sets up all the stuff that you would need to get up and running without having to like figure out all those intricacies. And then as your application grows and it gets more complex, you can tweak it. But it's like a way to get up and running in 10 minutes rather than having to do like a week of learning how to set everything up. So this is Scaffold ETH that has that NFT contract. And like, I don't know, I have some ideas for like weird stuff that we could do here, but does anybody have like ideas for a feature we could add to this application, which is right now it just allows you to mint an NFT for free and then transfer it away?
Can it change over time?
Sure. So let's see what would happen there. And then this is like coding improv, so I might have like I might run into issues. So let's see, how would we do that? So the thing that describes what an NFT is the token URI, and right now it is just when I ask token URI, it's calling some function called super.token URI, and what super means is it's like calling the parent contract, which is this ERC 721. So let's open that file up and see what that looks like. ERC 721, cool. And function token URI. Okay, so right now what happens with token URI? It makes sure that it exists, and then it like concatenates. It concatenates the base URI with the token ID. Okay, so it's like looking on IPFS and it's looking for like token ID dot one or something. How could we make it so that, let's see, do all of these look the same? Your collectibles. All right, let's mint an NFT. Let's actually mint two and see if we get a different one. Cool, zebra. So what if we made it so that like after half an hour, the buffalo turns into a zebra? But we can make it faster than that. So debug contracts. Let's check what the token URI of 1 is. And so it is this. And let's check what 2 is. So this will be like a hack that will only just barely work, but it'll kind of get us to that feature. So token URI. Let's make a new variable that's called like mint. Actually, let's make it a mapping. So public mint time. And we're going to store the time at which something was minted. And then let's make another function that's like another function that is how long of a delay we want to do for the buffalo to turn into a zebra. So let's see, change time, and let's make it a constant, and let's say that it will change after I think that this might be like milliseconds. Whatever, let's just say 30 for now, and then we can increase it if we need to. So inside of token URI, or inside of mint item, let's set mint time for token ID is equal to block.timestamp. And then inside of token URI, let's say if now is greater than mint time of token ID plus change time, then token ID is equal to token ID plus 1. I have no, that might work, that might not work, but let's try. So yarn deploy. Oh, now. It doesn't like now. If block dot timestamp. Okay, that deployed. Let's go to our application. Refresh. I'm going to mint an NFT. Mint 2. So we have a buffalo, and it was minted, let's see, mint time. It was minted at this point in time, and maybe if we wait 30 seconds, it will change into a zebra. Let's grab token URI. Oh, did it change? No, it has not changed yet. Let's see. Now it's time for some debugging. So let's see. If block.timestamp is greater than mint time plus change time. The nice thing that we can actually do is add like console logs. Or let's actually add a function that so that we can see what now let's add a function called now time. Public view returns unt56 return block.timestamp. Okay. Before we let's try deploying this one. Cool. It's deployed. Let's refresh. Mint a couple NFTs. All right, so mint time for token ID 1 is 164741228. And oh, you know what? I think that when I'm doing when I'm using like a local blockchain, the time doesn't actually increment unless I like mine new blocks. So let's do some other stuff and see what happens. Oh, okay. That triggered it. So I'll explain what happened. When you're using a local blockchain, like it's not constantly mining blocks unless you're doing transactions. But when I transferred it, it triggered the local blockchain to update, and our buffalo actually turned into a zebra. So like, it did it did do the thing. It's a little hard to understand. But like, does that make some sense as far as like what I modified? Like I went into token URI and like checked to see if the time had updated, and if so, I returned a different. I returned like the zebra instead of the buffalo. Does that make sense?
Can I ask you a question?
Yes.
So it wasn't actually related to the time, but more like which block number it was?
Yeah, and so every block that gets mined in Ethereum has a timestamp involved, and that's how we make things that update over time on Ethereum. Is like we check in a transaction or inside of a view function what's the block timestamp currently.
Yeah, and because she didn't add a block, it couldn't find a new timestamp.
Exactly.
Yeah. Okay.
And so once we added a new block by transferring the second NFT away, it made the first thing realize, oh, there's a new block we can update. And blockchains are usually quite consistent at adding new blocks. A couple weeks ago, the Polygon blockchain went down for like 12 hours, which was like really annoying. But the main Ethereum network has never gone down until now. Cool. Any other features? Otherwise, I can show you guys a cool like SVG NFT thing. Okay, let's go to an SVG example. So I'm gonna turn this off, and I'm gonna start a different blockchain. And all of these things that I'm messing with today are fully open source. So like if you want to like pull these down and start messing around with them on your own computer, it's all public and yeah, easy to use. All right, we have a new here's a different application. This is like a very simple SVG NFT example. The difference between the example that we did before was that when we asked for token URI, it just sent us a URL. So it took us to like IPFS, and then it grabbed the and then that variable. I can show you. So it went to IPFS and it grabbed a link, and then it just grabbed like a static image from that link. So let me connect here, connect to Rinkeby, sign in. I've minted some example owned. Here's a bunch of stuff. Let's see if I have any of the Austin's Buffaloes on here. Here we go. So these are actually the same NFTs that we were messing around with locally, but on Rinkeby, on the Ethereum testnet. So if I go to this smart contract, I can go to the testnet browser, find this contract, read the contract, read the token URI for token ID 1, and it gives me this link. And so this isn't the data itself, but this is a location where I can get to the data. So if I use gateway.pinata.cloud/IPFS/this, I can see that like, okay, my smart contract pointed to a URL which pointed to this file. And then when I want to actually find the image, it's actually at Austin Griffith's website. So like this is not stored anywhere on chain. The on-chain thing just was a URL that said, hey, Rarible, if somebody mints this NFT, it should look like this thing at Austin Griffith's website. If Austin wanted to, he could actually upload the zebra instead of the buffalo, and then people's NFTs would change. And so that's like kind of a criticism that, or not criticism, but like because everything is possible and fine and like has different use cases. But this is not an example of like a permanent on-chain artwork. This is an example of like this NFT points to this off-chain artwork, and Austin could at any point change it from a buffalo to a zebra to a flamingo. So as opposed to an SVG NFT where the actual code for generating the image is stored on chain. And so is a bit heavier, at least as far as the code, but everything that you would need to create those images is stored on chain. So I'll show you what that means. SVG example, packages, hard hat. And so Austin's very simple SVG NFT is called a loogie, just 'cause it's like a little round creature. And inside of token URI, you can see that there's a ton more code here. It's not just like return URL. It's actually like concatenating a bunch of strings to create an SVG. So the image is coming from base64 encode generate SVG of token. And so if you're familiar with like how like SVGs work, like it's a bunch of like descriptions of different like line strokes, line weights, and colors. And so inside of this is actually the Solidity code. Inside of the Solidity code, it's like, okay, let's randomly generate a loogie. If it's a weight of 50, then the radius of this circle should be 50. If it's a weight of 40, the radius of this circle should be like 40 pixels. And you can like do all of those edits directly inside of the smart contract rather than just like hosting a picture at your domain. SVG NFTs are how like loot is created. So like that loot NFT, that's just a bunch of words. Those words are just randomly selected from a word list and then concatenated into an SVG string and returned by the smart contract. So if I go to this demo application, I can mint a loogie. I have to get some funds from the faucet first. Cool. So I have a little loogie whose chubbiness is 43. And this image is not on a server anywhere. It is, let's see if I can see what happens if I look up token URI. Okay, inspect this. I actually want to grab this. So it returns all of this data. So this is much longer than a normal token URI, but let's mess around with this and see if we can recreate that image. So this is, I'm going to delete some of the prefix stuff. So this long string that's like E, Y, whatever, like this giant bundle of garbage is actually our image. So it's encoded version of a file, which also includes our image. And so I'm just going to go to a website called base64decode.org, paste this giant bundle of non-human readable garbage, and out I get something that's slightly more human readable. So I can see, okay, this is loogie number 1. It has a color of ECC87B and a chubbiness of 43. And it also includes another bundle of non-human readable garbage. So let's grab this, decode this, and oh, this is an SVG. And so like I can grab that and go to SVG render online, paste it in here, and I can see it. So like all of this data is actually stored inside of this smart contract. If I wanted to go into the contract and change the rules for how it's generated, like change the colors that are possible, change the radiuses that are possible, you can do all of that within the smart contract because the art is purely on chain. And there's a ton of cool stuff we can do with it that I'll show you in a second now that it's on chain. But first, any questions on like kind of SVGs or how SVG NFTs get created? Cool. My favorite thing about SVG NFTs is how they can be combined with other SVG NFTs on chain. Like there's this website somebody made called fancyloogies.com. Again, these are all just like developers having fun with like what's possible. So this is not necessarily some sort of high art or anything, but like this is an example of like developers creating tools that ideally somebody with art skills comes in and does something cooler. Because as developers, people added like eyelashes or mustaches to their loogies. But you could imagine any SVG art that you could think of, you could do something similar with. something really cool that you can do with loogies is add them to send them to another NFT. So we talked a little bit earlier about NFTs that own other NFTs. There's not a whole lot of examples of this like in the actual like NFT art market yet, just because like you still kind of have to know how to use smart contracts to add a feature like this. But let's make a tank, like a fish tank. And so our fish tank NFT is a blue square. If I were to look up the token URI of this, all it would give me is a SVG of a blue square. But what if I wanted to take my loogie and transfer it into the tank? So transfer, and now he's floating around. So like, I know this is ridiculous, but like, just think how cool that is. That like, this is now an NFT that is rendering another NFT being owned in this collection. In our example, it's like a little loogie that's being owned by an aquarium. But in your case, maybe it's like an actual like on-chain art gallery that displays SVG art like inside of it, and like the gallery NFT itself owns the NFTs inside of that gallery, and then maybe you like transfer the gallery as a whole. Like you can do anything that you can think of around like more complex dynamic interactions like that are all possible. I can mint another loogie. Oh, go ahead.
Does the original NFT have to be an SVG NFT, or could you say, I have these NFTs that already exist, but they're more like IPFS hosted, and if you own that one, you can like add a SVG layer on top of it or something? Or that would isn't an SVG.
It's all possible because like if the on-chain so there is actually a way to do layering of PNGs inside of an SVG NFT. Inside of the marketplaces don't really support it yet, but I've been playing around with it. It's like an SVG image tag. So you can include an image tag inside of your SVG, and then just put like the IPFS link to the image. And then if your website is set up to render that, which is just like slightly non-standard, then you can actually layer PNGs inside of an SVG.
Right. So like, yeah, you could take existing NFTs and make a new NFT out of that.
And you could like layer them, or you could like make a mosaic of them where it's like, okay, this is in the top left, middle, top right. Like you can make a mosaic of like PNG NFTs that are like a gallery.
Yeah. Cool.
So let me look at our loogies. So now we've got two loogies floating around in here. Let's just add a third one just for fun. Let's see. Oh, now we got a big fat one also floating around in there. Just like one other example on loogies before I just want to kind of get to some more Q&A and questions, is like, what if we wanted to incentivize people to send their loogies into a tank, but like they didn't want to lose their original artwork. So inside of loogies, I actually wrote this function last night to make sure that it would work. I took the safe transfer from function, which is like the function that's used to move the loogie into the tank, and I added a line of code to it called mint item. And so what's going to happen now is every time you transfer one of these to somebody else, a new one gets born. So that's like a way of like, and you could make it so that the new one is an exact clone of the old one. You can make it so that the new one is like a little like more transparent version. But now if I mint a loogie, wait a minute, I need to refresh. I'm gonna mint a tank. I'm gonna mint a loogie. I'm gonna transfer it into the tank. Remember this guy's green. Once I refresh, now I have loogie number 2. And I'm going to transfer that into the tank also. And refresh. Now I have number 3. So like all I've done is added one line of code to my smart contract, and I've completely changed the dynamics of this system. Like now, anyone can add their art to a new collection, and then they always get some sort of like artifact in return. Like you can add like any of these rules that you can think of, like just be, and that was just one line of code. This like mint item thing. So you don't have to be like an expert in coding to be able to start playing around with like different features like this. So I'm going to pause there and just ask like, what about like smart contracts is interesting to you? Like, what have I not covered that you would find interesting? Do you have any ideas for like things we can mess around with loogies or yeah?
Hello, Isaac. Thank you very much for this presentation. I actually have a question about how we can. I actually deployed my contract, my smart contract on Manifold, and I want to actually kind of list it on my own self-hosted website. On my WordPress website, for example, that I have, that's my personal website, and kind of wanted to make this kind of button, for example, to actually let people actually interact with the NFT and buy it directly in the website. What kind of resources do you recommend me to actually check out to actually do such a thing? And I really appreciate it. Thank you.
Oh, sure. So with Scaffold ETH, there's actually quite a lot of examples of applications for this. So like recently for ETH Denver, and for like these are just like a couple like PFP projects or whatever that launched recently, but you can see that they all kind of have this like standard looking UI, which looks kind of like the UI on the left. And that's because these are all just like template UIs that are using Scaffold ETH. So all of these websites are actually open source. So if we go to Scaffold ETH, so this whole website, that whole like Buffalo Unicorn minting website, is completely open source in this Scaffold ETH repo. And so what I would recommend is like, let's often people have like a WordPress or a Webflow site for their main site, and then at like a subdomain like mint.mywebsite.com, then they deploy a website like this, which is like 90% of what you need. It's just a matter of like taking your Manifold smart contract, like putting the artifacts in here so that it knows how to interact with it. And then adding like this mint button and then whatever UI you want around in the background. And then you can like host your own minting page. You could have some functions around like transferring it. So I would highly recommend starting with like some examples from the Scaffold ETH repo, because there's like hundreds of branches in here that will like get you most of the way there. Like moonshot bots. This is another Scaffold ETH website, and this is like completely open source. You can just like fork this and change the colors and add your smart contract, and then you have your own minting website.
Isaac,
Thank you very much.
do you have like a Google Doc with all the links that you shared?
Let me create one right now. That's a good idea.
Thank you. And is there a Scaffold ETH like for Tezos? A version of that?
There's not yet. So I've also been trying to kind of like learn the Tezos language and all that kind of stuff. I don't think there's not precisely a Scaffold ETH. I think that there must be some starter apps, but if you find them, like please point them to me as well, because I would find that handy in trying to learn how to do stuff on Tezos. Yeah, everything that I was doing today was kind of like more Ethereum focused, but like in the Tezos ecosystem, it's pretty much the same, just with like different resources. So instead of an ERC 721 or an ERC 20 token, Tezos has something called an FA2 token, which is which is like their token standard that you can. So I would look for like FA2 starter app, and that might be able to get you something similar to Scaffold ETH on Tezos.
And do you know if there's like a tutorial that's like maybe the equivalent of like the coding train for like really, really beginners
Let's see. Not
that
I
you might
know of, but
recommend?
I'll look around for like for Tezos specifically, or for like Ethereum also.
Yeah, just all this. I mean, just the lingo is so new for me personally that a lot of it is I know it's just kind of flying a little bit over my head.
So I think that Scaffold ETH probably is the best one, just because like it'll tell you what to install on your computer, as far as like that tool I was talking about called like Yarn and Node. Like it'll like teach you how to install all of those, and then if you can kind of get to that point, and then it's just like 3 commands to get it up and running, and then like you can just start kind of like poking around and messing with stuff. I think that that's actually the best way to learn to code, rather than starting from like scratch, because like I think it's very rewarding to have an entire application running on your computer and then go in and like change a word and see that word change on your screen, and then it's like that'll get you faster to deploying stuff, and then you can, as you need to learn things, go in and fill in the blanks with all the fundamentals. But yeah, I would start with something like Scaffold ETH, and then just start changing the lines on your computer, and seeing how it changes or breaks, and then trying to unbreak it.
Thank you.
How difficult is it so you showed SVG, so that's one way to make your work on chain. How difficult is it to attach more like JavaScript code or like HTML code to that instead of SVG? Step.
It would get a lot bigger and bulkier unless the scripts were like super simple. If you do it the more of the IPFS style, where it just is a link to the content stored off chain, very easy for an NFT to point to like HTML code or JavaScript code or something. But if you want that to all be generated on chain, it would just require potentially a lot more storage space or like more complex rendering. So yeah, SVGs are just like a bit more compact, which is nice.
Yeah. Okay, so then in
This
a
one
way
goes out.
it might be better to still just, unless you have a very compact script to store all that on the IPFS. Or your gas fees go out of hand.
Exactly, yeah. But in that case, like you can do stuff on Polygon or Gnosis chain and stuff like Gnosis chain. Things that cost hundreds of dollars on Ethereum cost like maybe a penny on Gnosis chain. So like that's like my favorite environment for like testing out things with real money, but not like crazy high fees.
Yeah. No, our blocks projects go into thousands, more than $1,000 mint.
All right. I started putting some links here. Paste them into the Discord. I'll add some more links to this as I remember what we went over. But I made it editable so that if you guys have links too, like you can add them here.
Sorry, I have a lot of questions for you. I'm very, very excited about this.
No,
What
please
are some of the most interesting things that you've seen done with smart contracts?
I saw a hackathon once where somebody made it was a very simple example of like an NFT that evolved over time, and it was like that classic image of like that classic evolution image of like ape, walking ape, Neanderthal, human, like, and like the NFT just kind of like aged over time, which I thought was really fun, and it was all entirely like on-chain art. I I like the ones where I like the audio ones where like the audio changes a little bit every time it transfers or has some like loss involved. Let's see, what else are people doing that's really fun? This is a bunch, but like yeah, can't. I'll have to like kind of dig through my links. Any that are standing out to you all that you're like wondering how did they do that?
All of them. I guess maybe one of the ones that is the most impressive is the Gazers one.
Gazers, I haven't seen that. So Gazers.
Yeah, it's Matt Kane.
Okay. Let's see. Very cool. Do they? So I see that it's like moving slightly. Is it like what's the general theme of that project? One frame every 12 moons. Interesting. So is it like constantly changing?
It's meant to change with the moon. I'm not sure. Like that
Very
land.
cool.
This is an Arblogs project, right?
Mm-hmm.
Or not? So it's not maybe not necessarily done inside their smart contract, but in the code of their project.
Mm-hmm.
Put those concepts also in a smart contract. I think I would be very interested to know what you would do with poetry, Anna Maria, with these kind of like things can change over time, or things can change when you know, the poem can evolve or change. That I would love to see that. That would be so cool.
I had an idea for this like remixing, or somebody else had this idea, but I've been like, I've just been like daydreaming about making it. Where, like, imagine you took a book and made an SVG NFT of every line of that book. Maybe it's like a short thing, like a poem, and then you made it so that, like, anyone that owns that that NFT could change like one word of that line. And then it would actually like re-render on chain, so like all of the words are stored on chain, and then somebody could choose like, okay, I'm going to change word 6 from this to this, and then you can kind of see how people collectively rewrite something through like owning SVG text NFTs.
Yeah, that's really interesting. There's a platform called Async where the NFTs change every hour on the hour, for example.
Mm-hmm.
I think,
yeah.
Anna, that would be the contract and not, obviously not the code, right?
I think it depends on how you do it. Like, I'm not sure if async does, if it like actually changes kind of how we change the buffalo to the zebra, or if like the content that it points you to just like checks what time of day it is. I have like one async piece that just like changes once daily. I'm not sure how it does it. I should look into that.
Yeah, should know the details more. And I guess the things that we saw in the course of Raphael, that were more things that you made use of the smart contracts of Theia or Hikanunk or FX hash, and then do things in your code that maybe interact with the address or with like some metadata that would pull it. So that's or maybe also ways that you can work on Tezos without coding the smart contract, but still having these similar concepts in an art piece. Just remembering that session that we did as well for people who are interested more in Tezos.
Mm.
I have a question. So, you've been doing this. You've been working on smart contracts for like 5 years. I assume like you're quite knowledgeable when it comes to blockchains. How do you conceptualize like what exactly Ethereum is? Yeah, because I would think that your view on the chains are much more in depth than, for example, me who joined in September.
Yeah. So to me, like, there's, I think there's this quote from Vitalik that's like, the future is multi-chain but not cross-chain. And like, I kind of believe in that because, like, there's tons of different chains that have that have many different uses. But every time you see like a big hack or a big like exploit, it's pretty much always like using a bridge that goes between chains that just kind of fails or goes down or doesn't work. So I think that like over time, things like roll-ups to Ethereum make a lot of sense to me for scaling. Because like I see the main Ethereum network as like this like super robust thing with tons of liquidity and tons of security, but is like way overkill for a lot of applications. Like if I'm like minting tokens that are related more to a proof of experience, or if I'm like managing a club's treasury as a DAO, like that's none of that stuff is what I'm going to do on the main Ethereum network, because it just costs thousands and thousands of dollars in gas to do it. Like I think Ethereum mainnet has its like its main purpose is like, if you need something with ultra high security or you need a market with like ultra high liquidity, that's where to go. But if you're like experimenting with stuff like on the fringes, like very happy to explore using other chains. Things like Solana, I'm actually like, I think that long term are overall like quite good, because while you have to have like a supercomputer to run a Solana node now, I think over time as computing gets cheaper, as it always does, eventually that will become more feasible for people. And so you'll be able to get kind of like the transaction throughput of something like Solana with more decentralization over time. So I think that like, yeah, there's a place for everything. And the Ethereum mainnet is Ethereum Ecosystem is my favorite, just because like there's so much more developer mindshare, and when you run into problems, there's so many more people available to help you that have run into that same problem. But over time, I think that like there's definitely a role for many different chains.
Cool, thanks.
Hey Isaac, can you hear me all right?
Mm-hmm.
Hi, I left you a question in the channel. I don't know if you could see it. Do you know a lot about Canon? Who are, I think they have a coin called K21, and they curated a bunch of different artists about 4 months ago, including sort of David O'Reilly, various artists of his sort of stature, I guess. And yeah, they're just doing some really interesting stuff with kind of long form, real world, IRL kind of stuff.
No, I haven't heard of it, but I'll definitely check it out.
I've sort of had a little look in their Discord, and like with a lot of these things, it's heavy on the coin chat and quite kind of quiet on the art, And I don't know. It's sort of like the work I've seen looks super interesting. But
Yeah,
I've
I'm watching
sort
one of
of
the
found
videos
it-
right now, and it looks like crazy cool.
Yeah, it's beautiful stuff, and like no one seems to kind of talk about it. And on the Discord, it's just like lots of bots going, when Lambo, where's my money, kind of thing. So
like the worst part of the crypto ecosystem.
yeah.
Yeah, that is really cool. Anyway, it's unfortunate when it's like you can't focus on when like when the attention's on the wrong is I guess my opinion. But yeah, some communities seem to be able to manage that balance, and some just kind of go completely in the direction of like pumping and shilling. Wow, like I have one of these videos playing from their website. It's bizarre. It's like some robot woman that's kind of giving birth. Interesting.
Yeah, I think like their kind of concept as well is this idea of a vault. So there's a fixed amount of I don't know, money or kind of coins or whatever, and all of the art goes into a vault for 100 years. So, and I think the artists they've commissioned and curated get some of that, or they get, kind of a percentage or something of it. Yeah, it's super interesting. I keep sort of like keeping an eye on it from afar. But yeah, it's a mystery.
That's really cool. I like those like the communities that do that kind of like long-term endowment planning where they have a community that forms to manage around a mission like that. I think that like adds sustainability, as long as of course people stay engaged and can like and contribute to it. But yeah, I think like having the ability to create a community around a project and with some sort of treasury like seems kind of essential for like long-term alignment of interests. These are some cool videos. Nice. Well, I'll just be distracted looking at those today then. There's a question around our.
Hey Isaac, we have a question in our chat. I don't know if you can see it. It's from Shabeli.
Yeah, Artiva. I'm not aware of that. So I've been looking around for sites that may display NFTs on my wallet as it was a website. I have found Artiva. Let's see. So you can build your own NFT marketplace. Interesting. This looks useful. I haven't seen other things specifically like this besides I know that like you can like Rarible has some like white label options where you can take take some of their marketplace components and then like skin it and make it look your own. But yeah, this looks useful.
Hi, can you hear me? I'm always quite unsure about my microphone.
Yeah, I can hear you.
Cool. I've got a question regarding this demonstration you did where you sent like one SVG into another NFT, like with the fish pond. Has it happened that people sort of hacked NFTs? That this group of people just decided, okay, there's this NFT that has huge value. Let's just basically destroy it by sending some, whatever, add another layer. Has stuff like that happened, or is that just possible, within the same smart contract that if you deploy the contract, then you're the only one who can add?
Any rules are possible. Like you could, I don't think I've seen an example where it's completely open. Like you can send whatever token you want to something else. And but if somebody did create that feature, then it would definitely be like open for possibly being defaced and stuff like that. Like that would be my concern. That was actually one of my concerns around that poem and word remixing project is like, do we have like some sort of like hate speech override button? Is that necessary? So yeah, anytime that you leave something completely wide open, it probably is gonna over time deteriorate into typical like internet awfulness. But you can make whatever rules you want. Like you can make it so that only people that own this other token are able to modify this token. Like all of these rules are possible to add into smart contracts.
Cool, thank you. Cheers.
Any other questions? I'm always available for just at me in channels or DM me if you have questions about what's possible in a smart contract, what's not. If you find a cool resource that you're interested to get an opinion on, always feel free to message.
I actually just have a really quick question. It's not more code based. It's more like gas, I guess. I remember looking at one of the works one of the early crypto artworks that sort of responds to itself through the contract. And my biggest thing is that sort of gas intensive, or once it's essentially like written and launched, you don't have to put any more gas, and it just sort of responds to itself and like is able to run. Okay.
Once it's deployed, it doesn't cost. There's like an upper limit to how much you can do, but it doesn't cost you anything to do that. So like the first time you deploy it with all those rules, if the rules are complex, it would like cost you more money to deploy the smart contract. But every time the marketplace is viewing it, and if that view function changes over time, it'll never cost you any more money to just like view it. If you need to go in and like do a transaction to update it, that would cost money. But like if it's just on its own updating over time, then that would the only costs are the deployment costs.
Perfect. Thank you.
I think we have time for one last question since we have kind of 10 minutes.
Sure. Yeah, one more question.
A question or comments, whatever you guys want to share with Isaac.
Can I ask something else? So if you know, like myself, or like probably a few of us, if you do it for the first time and you use the scaffold to get into it and try it, and you think like it works, you know, you do your test to your best of your knowledge, and then you deploy it. But then, is there something that checks it for you, or if you set it up faulty, that's basically your error? You messed it up.
Yeah, that's the risk. Is like people have created different standards for upgrading smart contracts over time. I would highly discourage that, just because it creates unexpected behavior for people interacting with your contract if at any point the logic can change. So the most important thing is like use highly audited things. If you're creating a new dynamic, get somebody else to at least read over it, to like look for common issues. There are some tools out there that will like do static analysis to look for common bugs, but those are not usually the things that catch the biggest hacks. It's like manual review and like finding someone that in your network that's like, hey, this is going live, can you please look for any common errors. But yeah, once it's out there, that's kind of like the nature of the thing, that unless you code it to be upgradable, then it's stuck.
Okay. Thanks.
Great. So I think it's the end of our class, Isaac. I just wanted to say thank you. This was an amazing and really, I think, insightful class. It will be the first one on YouTube. Who knows? Also, I
Right.
see that Anna Maria just dropped some collaboration ideas. So we can wait to see those too. And yeah, thank you so much, Isaac. This was amazing. And thank you so much, everyone, to attending this class and asking so many questions. Enjoy your
Yeah.
day.
Thank you very much, and I'll post a link to the slides.
Yeah, thank
you.
you.
Thank you.
Thanks, man. See
Thank you.
ya. Take care.
So much.
Bye.
Bye.
Thank you.